Hey everybody, this is going to be the fourth and final video on our series of rates of change for our calculus lesson regarding rates of change. If you're in my calculus class, hopefully you have the handout that I'm using to demonstrate this concept with. Otherwise, if you just happen to find this video on YouTube, there are three other ones that follow it, talking about what rate of or that preceded it rather, that talk about what rate of change is. You're welcome to follow along, and hopefully the examples are clear enough that you can make sense of them. But if anybody has any questions, of course, feel free to leave me a comment, ask me a question, see what you know, or see what you need to know. So here we have a model that's given to us for traffic flow at an intersection, given to us to be the function f of t is equal to 92 plus 5 sine of t over 2. And the time interval is going to be from 0 minutes to 30 minutes. So we have a half-hour interval that we're observing the traffic at a particular intersection. The first part of the question is fairly standard. It's a basic plug-and-chug exercise. If you happen to have a calculator available, you can get the approximate decimal value very easily. And of course, we're going to be in radians as we do this, but you just take the 8 and substitute it into the function. So there we go. F of 8 is equal to 92 plus 5 sine of 8 over 2, which would simplify to be about 88.216 vehicles. So we could round up or round down depending. A lot of people say, well, you can't round down, you just have to round up, and you can't have 2/10 of a car, but I would probably be okay with either you rounding up to 88 or rounding up to 89 or just saying 88 vehicles, because it's pretty close to 88. That's how we're going to look at that first one. Now moving on in the next part, it says make a sketch of the graph. So here you need to make sure you understand your transformations of functions. If you are doing this without a calculator, I would expect you to be able to kind of give a rough sketch of this if you've taken pre-cal or trigonometry or something. But here, go ahead and pause the video if you need to. Use your graphing utility if you have one, and you can kind of transfer it onto your paper. But go ahead and pause the video, get yourself a graph, and when you're done, go ahead and hit play again so you can see how your graph looks for mine. All right, welcome back. Hopefully you've got your graph all ready to go. So here we're only concerned really with quadrant 1, so this is how I'm doing it. We have the function f of t there where the independent axis, the x-axis, is in time in minutes, and f of t, of course, are your corresponding y values. So we have some kind of sinusoidal function like that. Remember the 95, that's going to be, or the 92 rather, that's going to be your vertical shift. Then we worry about, we can get the period and the frequency from the rest of the values of the function. But your function, the graph of the sine sinusoid should look something like what we see here. Now moving on, what is the average rate of change for the traffic flow over the time interval 10 to 15 minutes? So again, if we're talking about average rate of change, we're looking at what are the y values at 10 minutes and what's the y value at 15 minutes. So you do have to identify what those two y values are, and then take the difference of them and divide those by the difference of the 10 and the 15. So go ahead and again pause the video, figure out what the average rate of change is, and when you're ready, go ahead and hit play and check your work as it looks with mine, and go ahead and do that now, please. Okay, so hopefully you've worked out. You've had to use a calculator to identify the output values at 10 minutes and 15 minutes. And somewhere is my answer. There we go. So here we're looking at the average rate of change, which I'm looking at as delta f over the delta t, substituting the 15 and the 10 into the given sinusoidal function. We get about 96.7 for 15 minutes and about 87.2 for 10 minutes. Take the difference of those and divide it by 5, which is the difference of the 10 and the 15, and we get about 1.9 vehicles per minute. Now, make sure that you are not rounding the numbers in the numerator when you do the calculations with your calculator. Only round at the final answer. Now, the last part here, part D, and there's another one at the bottom, part E, but really this D is really the last big part of this example. Here it's asking you to estimate the instantaneous rate of change. Now, for instantaneous rate of change, what we've established in the prior videos is that average and instantaneous rate of change are basically the same thing. The difference being that for average rate of change, we can find it between any 2 points, regardless of the time interval between. However, for instantaneous rate of change, we want to have the time interval that's going to be extremely small, something that's very small, close to, approaching 0. So on our table, it is asking us to evaluate it for the particular values of 8.1, 8.01, and so on. So go ahead and, again, pause the video as you need to, so you can find the average velocities between the 3 given time intervals, and then we can use those given time intervals to show as it is approaching, as the difference in the time intervals is approaching 0, we can provide an estimated instantaneous rate of change. So go ahead and pause the video and work that out, and when you're ready, go ahead and hit play and see how your values look compared to mine. All right, so hopefully we have our numbers here. Now the first thing you have to do is you have to plug in the 8, the 8.1, the 8.01, and so on. You have to plug those values into your calculator so that way you can know what the output numbers are. Now here, these numbers are going to be rounded, but when I do the calculations with them, I'm going to save those numbers in my calculator. And when I find the average velocity for the first time interval, I'm going to get about 1.6 negative, and the next one I'm going to get about 1.6 negative again, and then the third one again about 1.6 negative. So hopefully you're able to get these values here and get particularly the rounded values here that I'm getting at the end, and the fact that the numbers are negative. And some of you may be wondering, well, why are the numbers negative? And the reason is that the rate of change is slowing. So that's why the values are negative, to indicate that the rate of change is slowing to about 1.634 vehicles per minute. And so why can't the instantaneous rate of change be calculated really using the method that we just looked at again? And this goes back to what we talked about in the first video about what instantaneous rate of change is in the first place. It is the fact that we can't use the method directly to find it at a particular instant, because the time interval at an instant is 0. So we have to have something close to 0 that's not exactly 0 in order to get an instantaneous rate of change. But that's going to conclude the series of videos for rates of change for our calculus notes. If you have any questions about anything, let me know. I'll be happy to get back with you on it. And until then, guys, thanks for watching. Take care. Be good to each other, and we'll talk to you soon. Bye.